Hi everyone. So in this video we are going to continue with dynamic programming in reinforcement learning, and we are now moving to our second algorithm, value iteration. So this time we will focus on the Q function, the action value function. So unlike in policy iteration where we worked on the value function, so in the value iteration, we directly update the Q values for state action pair using this formula. We can see it, yep, using this formula. So starting from the left, we have this term here, QLSA, which is the estimated total return from taking action A in state S at iteration L. So this also works in iterations like the policy iteration. So in each iteration, we apply this formula for all state action pairs. And okay, after that, we have the estimated reward from taking action A in state S. We have gamma, and also we have this probability. So this is the probability of ending up in state S prime after taking action A prime. And this term here is the future Q value of taking action A prime at state S prime. This here marks, here we are just picking the best possible action in the next state. That is what it means, but I'm going to give you an example. So let's just go to our example. We are going to be using this system, this 1D cleaning agent. So it can move left and right. We have a dustbin, we have a charging station, we have rooms from 0 to 5. And then this is our MDP. This example is going to use a stochastic environment to make it more realistic. So we have rooms from 0 to 5. Actions can be left, right, and the reward signal is +5 if it is at room 4. If it is at room 4 and decides to go right, the reward signal is +1 if it is at room 1 and decides to go to the charging station, and 0 elsewhere. The transitions will be 0.8 for the intended state. So if it intends to go right, it will achieve that with probability 0.8, and it might end up where it is with probability 0.15, and it might end up in an opposite direction with probability 0.05. Okay, now let's quickly compute the Q of state 4 and action right. So let's see, it is here. The agent is here, the cleaning agent. Well, the formula tells us take the immediate reward. Well, at state 4, if it tends to go right, the reward is +5. So it's going to be, sorry, it's actually +5 plus gamma 0.9. Let's see, gamma is 0.9 times, well, now if it is at state 4, it might actually, with probability 0.15, it might actually just stay where it is. So it's going to be 0.15 times Q of, when it stays where it is, it will be in state 4, and then based on the formula we have A prime. Okay, and there's a probability of 0.8 that it will really go right, achieve the the intention is go right. So there's probability of 0.8 that it will go there, 0.8, and then times Q of 5 next state, plus there's probability of 0.05 that it will actually go to state 3, an opposite direction, A prime. Now let me show you how to compute this Q 3a prime, for example. So q 3a prime is, but what does it actually mean? It means here 3a prime means pick the best q value at state 3 over all possible actions. So at state 3, the agent has a chance, can actually, let's say, go right, and let's say the q value of that is 0.6. The agent at state 3 can decide to also go left, and let's say the value is 0.7. Now the maximum is this. The maximum is this. So here q3a prime is going to be 0.7, and then you do the computation, you get a value, something like that. There's going to be a Jupyter notebook in the description that you can, there's going to be a link that you can play with. So this is really the summary of value iteration. So unlike, I think I should mention this, unlike in policy iteration, which has separate evaluation, don't forget, and improvement steps, value iteration merges these steps into one, which is more direct. Okay. Yep. So this is it. Thank you for watching. Let me know if you have a question in the comments. Bye bye.